Okay, so this video is basically if you are stuck and you don't know what to do. So in this problem, if we read it out, there are ninth grade students. They're going hiking and they measured body weight and then the backpack weight. And we're trying to predict how heavy backpacks are going to be based on the weight of these ninth graders. So our explanatory variable here is body weight and measured in pounds. And then the response is the backpack weight. This is measured in pounds also. And to do this, we're going to go click on the Statlet link. And we have those explanatory and the response. And we're going to copy and paste. So I'll grab the body weight first. I'm copying. I hit Control C. And then I'll do the same with the backpack weight. Control C, and then Control V. You can also be right-clicking and copy and paste. I'm going to begin analysis. I have the scatter plot. So while I'm here, I'll go ahead and I'm going to click the other two buttons here, the calculating buttons, calculate the correlation and calculate the least squares regression line. I'm going to need all this information as I'm filling it in. So I screenshot, and whatever your device is, sometimes you get the whole print screen. Sometimes I hit Command Shift 4. Sometimes it's the screen change with the square and the lines. Whatever yours is, you screenshot and then insert that graph into the doc. And if you ever need to crop it, you can double click and then grab those black bars and you can crop out the extra stuff that's on there. The next job is to describe the association. And I would say there is a positive, moderate, linear association between body weight and backpack weight. And there is some scatter, but it's really not too much. And if I look at the correlation where I hit the calculate button, it's 0.795. So that kind of reinforces that it's moderate. It's not super weak. It's not super strong, but it's also not super weak. For the equation, that's already on here. I just need to put it on, and I'm going to round just to the nearest tenth here. And so really I have 16, we'll round this to 0.3. So here, my equation on the line is y hat equals 16.3 plus, and then I'm rounding this one up to 0.1x. 0.1x. So for the slope, it's a good idea to know what the x and y are. So x is the body weight, y is the backpack weight. So this is really describing the backpack weight or the predicted backpack weight. Predicted backpack weight increases 0.1 pounds for each pound of weight. 1 pound of weight. I could also really say that 0.1 is really 1/10, right? So the backpack weight is going up 1 pound for every 10 pounds of weight. That's another way of saying it, but we'll leave it how it is. And the y-intercept, the predicted backpack weight is 16.3 pounds for someone who weighs 0 pounds. This does not make sense in context, but it's mathematically it works to have our equation like that. For our prediction, we're basically just going to plug this in. So my predicted equals 16.3 plus 165 times 0.1, or 0.1 times 165. This is not that hard to calculate. Without a calculator, I'm going to end up basically doing 16.3 plus 16.5. Grab a calculator if you need. The 16 and 16 is 32.3 plus 0.5 is 0.8. So I have 32.8. So the predicted backpack weight for someone who weighs 165 pounds is 32.8 pounds. And that's it. Make sure you ask questions if you have them. Joe IR is there. You can always put comments, but good luck and see you soon.